Did you know that most art historians dream of becoming data labelers? I'll take you back in time to the year 2020. The Royal Museum of Fine Arts Belgium concludes its pioneering project with AI. The goal of that project was to detect music instruments in artworks. How did they do it? Well, they used AI, of course, and more specifically, object detection and recognition. This resulted in a dataset, the Minerva dataset, with over 10,000 images. How did they get to that dataset? Well, they had to manually label all of the images in Excel. Imagine yourself an Excel sheet with over 100 columns, one column per class, per type of instrument, and they had to work like that. The question you should have here is, but why? And that is the right question, because the return on investment was not really clear. And even worse, if you think about it now, their approach didn't scale, because if you want to detect something new, you just have to start over again and again annotate 10,000 images. After that, we tried something different. We talked to a conservator who was interested in botanical models and paintings. And we asked ourselves the real question, and that is, how can AI help? So quite obviously, we want to avoid labeling. And we can do that because we have botanical archives by Sam Segal. We can process them with computer vision and create labeled datasets like that. And also, don't aim for the stars. Start small with an initial milestone. We thought about a fun app. We called it the Mother Days app, where you can pick flowers and create a bouquet for Mother's Day. I don't know if you noticed, but in doing so, you automatically need to extract flowers from paintings to have your flower picker. And you actually have an interesting data set at the end to be reused for the bigger research question. The Mother's Days app has 3 AI modules. The first one is object detection, we have one on segmentation, and we have one on generative AI. So the first one, object detection, detects the flower heads. And what the model does is it draws a bounding box. In this box is a flower. The segmentation model looks inside these boxes and says, well, these pixels belong to a flower. So they create some sort of a mask to extract the flowers. Then we have in-painting. In-painting is a generative AI model that creates a bouquet from the flower heads. But what does it do? Well, it creates missing pixels between the flowers and the vase. So what is between the flowers and the vase? It's actually the stems and the leaves. And the model predicts how they will connect to each other. So how does this work technically? Well, we have an object detection model. In this case, we used a YOLO model. The model, I already mentioned it, draws boxes. And per box it says, well, I will assign a class to this box. In this box is a flower. YOLO V8 relies on a very classic deep learning model called CNN, or a convolutional neural network. They already date from roughly 2014, and they were one of the big breakthroughs that sparked deep learning. What the models do is they detect local patterns in images, in our case, flower heads. The segmentation, we used a model called Segment Anything by Facebook. What does this model do? It looks at individual pixels and decides for every pixel whether it belongs to a class or it belongs to a flower, yes or no. So we get very precise shapes or masks. And if you think about it in a more physical way, it is actually a model that allows you to do a perfect cutout with a pair of scissors of the flower heads. I haven't talked about labeling 10,000 images, have I? Well, this is because we're not going to do that this time. We took foundation models, like the YOLO model, and we fine-tuned them. What does that mean? Well, we started from a model that could do something completely different. For example, a model that detects faces. And a model that detects faces has to do a lot of things in order to do so. It, in fact, first learns to analyze your image. And only at the very end does it start to make distinguish between different types of faces. So if we take the first so many layers of the deep learning model and we freeze them, we do not change them, we already have a very good preprocessor. And when we add a couple of new layers, fine-tune them, give it some new data to learn from, and it suddenly becomes a flower detector. How did we do that? We collected some flower images from Wikimedia, applied data augmentation. That means we took an image, for example, we had 30 images, we wanted to have 100. Well, we could mirror them, flip them, add some distortions to them, and feed them to the fine-tuning algorithm. So because the more images it sees, the better it becomes at adjusting to the new task of flower recognition. Segmentation, detection, they have a lot of use cases. For example, if you think about segmentation, we also used it in newspaper segmentation to try and find the exact position of the articles. We use it for herbarium sheets, and we use it in historical maps. Are humans completely out of the picture now? Well, I already mentioned, we used, of course, the human input for fine-tuning. But sometimes crowdsourcing is really the entire picture. So in that case, think about the Excel sheet. Humans have to make the annotation to the image. Do we have to use an Excel sheet? Well, I would say no. We have better tools now. One is IIIF, a standard for visualizing images and to add annotations to them, to add stories to them. This is a framework, it's web-based. That means it's easy to share everything you say about an image, and you can even work together, co-creation. We don't only use it for storytelling. At the museum, we also use it for damage annotation. As crowdsourcing is still labor-intensive, we wanted to help the people a bit, because annotation is hard, but validating is more efficient. So we extended this interface with AI plugins, exactly the ones I talked about for detection and segmentation. So actually people see a pre-annotated image and they just have to confirm that the annotation is correct, which is much faster than doing everything themselves. So my takeaways here would be no, the obvious one. Art historians are obviously not just data labelers. They can help a lot, but in a targeted way. For example, crowdsourcing, fine-tuning. We saw basic computer vision algorithms at work. We learned about detection, segmentation, and in-painting. And maybe as a general advice for your AI project, I would like to say, try to be a lazy labeler. Don't label too much. Otherwise, it's probably not what you're supposed to do. And start from a need, the botanical collections. Find milestones, the Mother Days app. And in reaching those milestones, collect feedback all the time and improve.